And I think we should be live. Wait a minute for people to join in here. As you're joining in, no matter where you're watching, make sure you say hello in the chat. I'll type there as well. I see some people here already. It's always fun to hear where you're watching from as well. If you're tuning in, maybe also a little bit about what you're working on or why you're interested in machine learning pipelines or what you're building right now with ML models or any projects that you're either learning about or working on. It's always kind of cool to hear about. And again, we'll get going here in a couple minutes. It's not even quite 10 yet. So I'm sure more people will be joining. Somebody said hola in the chat. Hey, welcome, welcome. Where are you watching from? And I'm going to share my screen. Again, we're still even a minute early for start time. And more people will probably be rolling in, and I'll go through some setup instructions. And I'll mention this again, but we're going to go through some slides, and then this is going to be like a hands-on follow along workshop. If you want, you can also just watch me, but it's more fun if you probably follow along. And while we're waiting for people to join, I'm just going to quickly check to make sure that we are streaming in the right places. Looks like we're good. We'll give everyone a couple more minutes to join in. But like I said, it's always fun to hear about where you're streaming from, what are you working on, why are you interested in like the stuff we're going to cover in this workshop. I'm streaming from Seattle, by the way, which has been very nice out lately. So I'm excited to do more stuff outside. And let me just fix my door real quick, actually. And I'll check one more thing as people are joining in. Just making sure people are finding the right link. Cool. Seeing more people join in. Again, as you're joining, say hello in the chat. Maybe also mention where you're watching from. And I'll share some links. So if you're watching on YouTube or LinkedIn, actually, should also have the links in the description for everything that we want to do today to follow along. But the main thing that you probably want to do to set up before we get to the hands-on part is to sign up for Union, which is a tool that we're going to be using today. And I'll talk more about that shortly. It's built on top of a very popular open source tool called Flyte that's very widely used for MLOps and ML pipelines. And all the stuff we're going to do today, you'll also be able to do in Flyte if you want to set up the open source on your own cluster. You can do that. But for the workshop, we're going to use this serverless version of Union that makes it really easy for us to do everything without having to set up our own Kubernetes cluster or anything like that. And you can use serverless outside of this workshop as well, or Union. I mean, that's kind of the point of the tools. It makes it very easy to set up infrastructure. But we're going to see kind of serverless today. But just keep in mind, if you did want to spend time and set up your own cluster with Flyte, you can do that as well. And then the GitHub for this, again, it's in the description, but I'll share them in the chat as people are joining in here. There's a GitHub link here. This is going to be where the notebook is. You can open it up in Google Colab, so you don't have to set up any environments locally, and you'll be able to run it hopefully very smoothly here. And then also there's a Slack channel, again, in the description as well. If you want to join that Slack channel, say hello in the introductions there. Outside of this workshop, that'd be great. I'll be looking at the live chat today, though. So if you have any questions, make sure you put them in the live chat on YouTube or LinkedIn, and I should see them. If you have any error messages or anything that requires like a longer thread or maybe images, you could post them in the Slack channel. And I just made a channel called Live Workshop. So if you need to troubleshoot something, you can do so in there. And all right, I'm going to wait just 1 more minute or so as people are rolling in here, and then we'll get going. So again, please say hello in the chat and maybe where you're watching from. Make this full screen. Also, people can hear me and see me, I hope, and see the screen. I'm going to assume yes. I haven't heard no, which is worrying. or yes, yeah. So all right, we're going to go into this workshop, Intro to ML Pipelines. Again, all the links are in the description. One caveat is if you're watching this recording later and you sign up not during the time frame of the workshop, it might put you on a wait list for a little bit, but you should get off that wait list pretty quickly. And I just saw a chunk of people come in, so welcome everyone. We're just getting started here. Say hello in the chat, maybe mention where you're watching from, and then all the links I'll share again when we get to like the hands-on part. All the links are in the description, and I did share them in the chat as well, so you should be able to see them there. A tiny bit about me. My name is Sage Elliott. I work at union.ai. I live in Seattle. I've been running a really fun AI book club as well, so you could join the Slack channel and learn more about that in the AI reading club. If you're interested in reading books, like we've been doing a book a month, which has been really exciting this year, and I've really enjoyed it. Previously, I worked a lot with computer vision. That's one of my favorite machine learning areas, and I'm excited to actually do more with like pipelines and computer vision too. So if that's something you're interested in, follow me or let me know. We can make content around that. And also I've worked a lot in ML monitoring. So like once a machine learning model's in production, how do you make sure it's like performing well, do evaluation on it. And then also I love working with like hardware, IoT, and MLOps. And if you want to stay connected with me, best place to do that is probably LinkedIn or in the Slack channel that I shared earlier as well. Again, I'll share that Slack link one more time if you want to join in there. And about you. So again, people joining in, chat has been fairly quiet. I do see Amber said, hello from San Diego. Hey, how's it going? And again, put in the chat where you're watching from. What are you working on? Why are you interested in ML pipelines? It's always fun to hear about like kind of people's backgrounds and maybe what you have in mind. And I can sometimes tailor a little bit about what we're talking about, maybe to something specific if you're working on a specific project. And again, I'd share the Slack link. That's going to be a good place to stay connected. And there's an introductions channel. You can say hello in there and introduce yourself to way more people. I think there's like over 3,500 people in there right now. It's a pretty fast growing community. So it's a cool place to be. Quick overview for the workshop today. The core of it that you're probably excited about is going to be building the machine learning pipeline workflow. We're going to talk about, we're going to do all these things hands-on. If you're following along, we're going to create a container image. We're going to download a data set. We're going to process the data and visualize it. We'll train a machine learning model. We'll evaluate that machine learning model. And then we'll also save that model to a model hub and then talk about how to bring that down into different places. And we'll do this all in a reproducible machine learning pipeline that's, basically how people do this in real life in a lot of big companies in production. And we'll talk about why you want to do that as well here in a second. So we're going to cover some concepts, overviews, which will be in some slides. Again, this isn't going to be all slides. It's going to start with some as we go over kind of the basics here and get everyone on the same page. And then we'll go on and do hands-on, where I'll give you a Colab notebook. Again, link is in the description if you want to start following along. And we'll actually go and build this workflow that I just talked about. So we'll do a little bit of setup. We'll build the machine learning workflow. And then also, just want to mention, depending on your level of experience, like, maybe the code might seem really like something you've never seen before, or this workshop could feel a little fast paced. And that's okay. Just stick with it. No matter if you even haven't trained a machine learning model before, you'll be able to run all the code, train a machine learning model, and have it done in a reproducible pipeline, which will be really cool. So stick with it. It's okay if it feels fast paced. So if you've never built a machine learning pipeline before, or delved into like MLOps, which MLOps stands for machine learning operations. At the core of that is usually building out a pipeline that might look something like this. It definitely varies in what you're doing. If you're using like LLMs or different machine learning models, but MLOps is a set of practice and tools that aim to deploy, monitor, and maintain machine learning models in production reliably and efficiently. is kind of how I like to think of it. So you've probably seen maybe something like this before if you've looked at ML, where you're going to be collecting data. You also usually do another step of like some sort of pre-processing on the data, which we'll do a little bit of that today. Then you're going to train a model. Often you evaluate that model once it's trained to make sure it's actually working how you expect it to. Then you're probably going to ship that model somewhere. And again, we'll see this in action as well. And then often when your model's in production, you should have some form of monitoring on it to make sure that it's operating as expected and that any data coming in isn't going out of those expected realms. We won't be diving deep into this today, but I love talking about it. I think it's really interesting. And talking about people monitoring ML models in production is interesting. Like a lot of people know that they should be doing it, but they don't always have it properly set up right now. And then once you have that set up, you pretty much consistently want to be improving your model. So, you don't really put a model in production, just leave it. You're usually collecting data again. Like this kind of becomes a whole loop here. You're collecting data from production, making sure you're getting use cases that aren't in your data set, and then retrain your model with those use cases and evaluating to make sure it's continuously working. So it's usually this continuous thing where you have like a pipeline that you want to keep rerunning, again, reliably and efficiently. And we'll talk about some of the ways to make this more reliable and efficient. And again, like this is an example pipeline. There might be way more steps to it. If you're working with large language models, you might have vector databases, guardrails. There could be more A/B testing and shadow deployment for models. So like you might have one model in production making decisions. You train a new model. You put the second model out, running it on production data, but it's not actually making the decisions. And you can monitor both of those models to see which one is better and then roll that new one out if you do think it's better. So this is pretty common practice, especially if you have use cases like a self-driving car where just shipping a new model into production could cause some issues, and you want to make sure that it's actually going to be able to like do self-driving reliably or more reliably than the old model before you put it in production. You might have seen the MLOps or machine learning tool landscape before. This is just such a tiny example of all the tools out here. There's so many different ones. But has anyone used any of these tools before? Let me know in the chat. Again, kind of like that pipeline, you're often doing things like extracting data, doing processing or transformations on that data, validating that data. Again, making sure that data is as expected, exploring it, training it, testing, deploying, monitoring, and retraining. Someone in the chat said life cycle. Yeah, I think I didn't put that word here. That's the machine learning life cycle is kind of what this is. And I like to think of it as a continuous loop between, again, more steps than this often, but between all those steps in your pipeline. You want to be able to rerun those as efficiently as possible, usually. Someone said they're interested in MLOps. Been learning AWS cloud solutions, architect, and data engineering and ML. It's a big bite, but I enjoy it. Yeah, there's so much to learn. Also, today we'll be talking about kind of this ML pipeline side. A lot of what you're going to see here, you can also use in data engineering as well. I mean, data engineering is such a big backbone of the ML lifecycle that not everyone always talks about all the time. Just a quick note on like orchestration. So we have all these tools that we want to tie together to do all those different steps that we saw in our pipeline. We can use something called orchestration, ML orchestration, AI orchestration, data orchestration. You could call it different words like that, but at the end of the day, we're basically managing these libraries and managing the compute that they're running on and allowing them to do all those really cool things that we want in our ML pipeline. So again, I've mentioned the words like reliable and efficient. Those are things I like to think about when building a pipeline. You want it to be scalable, so it can facilitate scaling of your AI workloads to handle large data sets and complex models. We've seen like GPU-rich people right now. If you're managing all this compute to train your models on, you want to be able to scale up and scale down based on what you're doing. Again, we'll see some of this in action and some more examples here in a second. Reproducibility, you want to ensure that your workflows can be consistently reproduced. And also version. So like each workflow that we're going to be running today gets a version in it with the artifacts that are generated from there. So you can actually track all the data, the code, and all those model versions generated every time you run that lifecycle that we talked about. You want to have improved efficiency. So you want to allow your data scientists or ML engineers to focus on, model development, not necessarily all of these tying together all these steps in the pipeline. And then a big thing too is cost efficiency, especially when you're training very large deep learning models. there's a lot of stuff to think about there that we'll dive into. So want to optimize your resource usage, reducing overall cost of developing your AI models. But also, if you have improved efficiency between your team, that's a big cost improvement as well. And again, we'll see kind of some ways that we can do this. So optimize for local development. These are kind of some of the top 5 things. Like if I was choosing some sort of orchestration tool today that you might want to keep in mind. Obviously, it depends on your use case. But here's some things that we found, like when I talk to people, that are really good cost savers or efficiencies boosters for their ML pipeline. So this sounds really obvious, but utilizing your local computing resources over like your expensive cloud for testing and iteration. I know like at work, so many people have like M2 MacBooks. That's really good for, even training some PyTorch models on. So if you're just like iterating in your ML pipeline, you should be able to run it locally, even if you're not doing a full training job on there yet. But basically for debugging and maybe some test runs, you shouldn't be always spinning up like your expensive cloud. It's also really fast. You don't have to wait for containers or anything to spin up. You can just run it locally, get feedback, change some stuff before you kick off like a run in production cloud. Leveraging caching in the pipeline. We'll actually see this in action today. So this is a really big benefit, especially if you have a very large data set or something like that, or you've done a large training job and then you want to rerun other tasks in your pipeline, but you don't want to rerun the whole pipeline from scratch because you don't need to. You can use caching inside your pipeline. So this example like illustrates, you get a data set, you pre-process that data set, and then you might want to train that model several times with different hyperparameters. But instead of running the whole workflow every single time, you can cache those ones that you say, well, I don't need to pull a new data set. I don't need to pre-process it again. I want a version of that to live here, and then just pull that in for training the model. So there's a lot of interesting use cases you can use caching for. Task level resource management and containerization. So precise resource attribution for each task really helps here too. So a lot of times in some maybe older pipelines, people would build like a monolithic workflow where they would spin up one kind of compute resource for their whole pipeline. So imagine, we had all those steps of like pulling data, pre-processing data, visualizing the data, and then we get to training. And then after training, we're doing something else like moving a model around. Well, GPUs are very expensive. You might have already known this. And a lot of other computers as well, but definitely GPUs. So here we're kind of, for each of those tasks in our pipeline, we're defining exactly the amount of compute and the container that we want for each of those tasks. And again, we'll see this in action here too. But here, if we're pulling in a data set, for example, we only need like a CPU or a couple CPUs to pull in that data. We don't need the GPU yet. We only need that GPU for training. So this is only going to spin up those resources when they're needed and then spin them down. So you're not spending either a lot of money on those GPUs, or you might not have that many GPUs available in your cluster and you always want them available when you need them. So you're not kind of wasting them between all these other tasks. Mitigating errors with type safety. This is like who uses typing in Python? I see some comments in the chat. I'll get to those shortly. But if you use Python, it will actually see what this looks like in action as well. If you haven't used typing before, but essentially you're defining in your functions or tasks in this case, what kind of data is coming in and then what kind of data is coming out. And if the data coming in doesn't look right, doesn't match what you defined, it's going to automatically kind of throw an error there saying, hey, I was expecting a string and it was an integer, or it's expecting a data frame and it was a list. So you can define this kind of type safety immediately in your tasks. And actually in Flyte and Union, what we're going to use today, you're kind of required to do this. So it kind of forces you to actually write a little bit better code and conventions around your pipeline. Some people, if they haven't been doing typing before, they'll struggle with it very slightly at the beginning, but it's not that hard to implement. And then once they do it, they get really used to it and really like it. And then even if you weren't using Flyte or Union, you kind of tend to add typing into your code now. And then another thing to think of too is harnessing like economic benefits of spot instances and batch processing. So a lot of times if you're using like a cloud provider like AWS, they have something called spot instances where they have some compute up there ready kind of for you to grab that can be a lot cheaper than you already having to reserve that. You can check out more in the docs of Flyte of how you can do this. And then also we had a blog post I'll share in the chat of utilizing OpenAI's newer kind of, I think they call it batch pipeline or batch instances of the OpenAI API, which is a lot cheaper, and how you can utilize that as well. So thinking of like these different ways where sometimes it can be way cheaper to use this resource, or sometimes you don't need an immediate result and you can use the OpenAI batch API, which might take like an hour or two, but maybe that's okay for you. And you should think about how to build those into your pipeline as well, because again, that could be pretty cost saving. So for today, we're going to kind of see most of those things in action, not necessarily the spot instances, but we're going to be using Union to do the AI orchestration. And like I mentioned before, Union is built on top of Flyte. It's powered by this open source project that we're also some of the core maintainers of. If you haven't heard of Flyte, it's an incredibly popular machine learning or AI orchestration platform, and it's open source. So all the stuff we're going to use today, like I mentioned at the beginning, if you were here, you actually could go set up your own open source infrastructure here, but it makes it way easier for this workshop for you to get in on Union serverless and basically start running your pipeline right away with most of those things that we talked about. So we're going to see versioning, caching, type safety, and these platforms are incredibly flexible. You can bring in basically any type of model, any data sets to it. And then I'll also just quickly mention, because we're using serverless is in beta right now. So if you do see any bugs, definitely let me know as well in the chat here, or join the Slack channel if you have any issues and let us know over there as well. And a quick recap on machine learning. I'm guessing a lot of people here have done some sort of ML before, but if not, you can think of machine learning basically as we're passing data into some sort of function, and it's going to learn patterns from that data. And then we can pass it new data, and it's going to give us a prediction. So for today, we're going to use an algorithm called k-nearest neighbors. We're going to basically pass in this training data, which you can see here is plotted in this 2D graph. And there's 3 different classes of flowers. And then how KNN kind of works at the basic level is a new piece of data comes in where this black dot is. And if this was K is equal to 4, basically it says it's going to look at the 4 closest neighbors to the new piece of data. And in this case, we can see 3 are versicolor, which is a type of flower. 1 is virginica. What do you think this would predict just based on what you know right now? So it's looking at the closest 3 here, and it would predict this versicolor and maybe a little likely that it could be virginica. And we're going to be using a library called scikit-learn, which is a really popular machine learning library to implement algorithms like this. And then we're going to do saving and versioning models. So we talked a little bit about it as well, how every kind of instance of your output is saved in Flyte and Union. So we'll see that in action. But then also part of our workflow, we're going to save it to something called Hugging Face Hub, which is a really popular place to put models and data sets. If you haven't used them, you should definitely check them out. They'll be part of our workflow today. And this is a common workflow too, because you might train a model in Union or Flyte, and then you might want to move that model to AWS or somewhere where you're serving it. So we're kind of emulating that today here. And that's enough slides. So is everyone ready to actually follow along and kind of replicate some of the stuff that we talked about here? And I'll catch up on the Slack question or the chat questions here shortly as well. But if you want to follow along, again, these links should be in the description, but I'm also going to copy them in chat one more time as well. So first, you might want to go ahead and do that sign up. It's free sign up. There's no card or anything required. I think it just asks for your GitHub account. So you do need a GitHub account. You authorize it, and then you should be good to go for the workshop. And then the other link here is a GitHub link. You'll get up to a page like this. I'll add more to the README in the future. For now, though, all you need to do to follow along for the workshop is hit open in Colab, and then you should get to a page that looks like this. You don't need to make your own copy. You should be able to run all the code here. I tend to like to make my own copies when I'm running collabs, like from workshops. That way I can actually edit the code and text and have my own copy. So I'm going to hit save a copy and drive. This isn't required, but I do kind of recommend it if you want to make modifications and then play around with it. You can have your own copy. You can always come back to this original link later if you break something, and then just make another copy if you want it as well. So I hit save a copy. Again, you don't have to. And then if somebody in the chat wants to let me know that you got this Colab open, that would be great. Amber gave a thumbs up. Hopefully that's for this, I think. And then also, while you're doing this, opening up these links, and then you might want to go to that sign up page if you haven't already, because it just takes, it should be less than a minute to sign up. I think you just authorize with your GitHub, should be good to go. Also, if somebody wants to let me know, were you able to sign up successfully? That would be great to hear in the chat as well. And I'm going to scroll up on the chat while people are doing that real quick and catch up on some of the questions that I saw come in. And let me zoom in here too. That might look better for everyone following along. So if somebody wants to let me know you were able to open Colab, and if you were able to also sign up for Union, that would be great to hear in the chat. Someone said they know a bit about ML deep neural networks, but how to get data in. That's always a really good question, because a lot of resources too don't really go into data collection and data annotation, which is something I've done a lot of. And actually, I'm working on, I think, doing a workshop around like training your own computer vision model, and maybe something more exciting than just classification, like object detection. And with that would also include how to do data annotation. If that sounds interesting, let me know in the chat as well. But yeah, it's a very common thing. It's not just you. So many resources and classes teach about how to fine tune a model or train a model, but not about collecting data, which is in fact incredibly important when you're building your own models. They also asked about free open source LLMs. There's definitely a lot. There's a lot on Hugging Face as well, actually. Maybe we can dive into that later when we open up Hugging Face. You also will want a Hugging Face account, actually, for the last step in the pipeline. If you don't create an account, it's okay. You just won't be able to run that last step in the pipeline. So I do recommend having a Hugging Face account as well. That way we can save a model to the Hugging Face hub and then show how to download that model as well, which is, again, pretty a realistic workflow for something you might be doing in production. But there's so many free open source ones, and most of them live on Hugging Face, even if they weren't made by Hugging Face, and so it's actually easy to download them. Someone said, while signing up with GitHub, it says you're on the list. We will be in touch shortly once you have access. Someone says they're on the wait list as well. Let me double check something real quick. Also, so you should get an email maybe in a minute to get you off that wait list. And let me see. Yeah, let's wait a minute and see if you get, or let me know if you get another email saying like welcome. And while that's happening, you can start running some of these cells in Google Colab actually as well while we figure that out. So first, if you haven't run a code cell in here yet, you can hit this little play button, or when the cell is highlighted, you can hit Shift Enter, which is kind of my way that I usually do it. And that's going to run the code cell and then move to the next line. And the first time you run code cell, it might take a few seconds. It's actually spinning up a whole little instance for you here. So once this printed out, should be good to go to run the rest of the Colab. And then also, let's go ahead and pip install these libraries. This can take a minute or so as well before you need the Union access. So go ahead and hit Shift Enter here. And then if you haven't already, do the sign up for Union. And then also you can sign up for Hugging Face if you don't have a Hugging Face account as well, if you want to do that last step of the pipeline of saving a model to Hugging Face and then pulling it down. Again, if you don't put in a API key here, should be okay for most of the workshop as well. All right, so yeah, I'm just looking, and I think I'm seeing some of the people like in the log that if you signed up, I think you should have gotten an email probably now. I think it takes like a minute or two maybe for it to come through. So if somebody does let me know that they're off that wait list, that'd be great. You can also try to maybe visit this unless in case there's like a delay in the email to you. You can also go try to access this. Oops, sorry, that's my org. You won't be able to access that. Let me get just this first part of the URL. The serverless.union.ai. And see if you can open that up. Maybe there's a little delay in the email getting to you. And so my thing finished here. While you're waiting, cool. I see someone said they got the email. So let's wait a minute to keep going while people get those onboarding emails. Again, it might just take a minute or two, and then you should have access to something like this. I'll go back to the notebook here in a second. I'll just give you a very quick tour. If you go to serverless.union.ai, you should get a page that looks like this. You won't have these runs in here because you just signed up, unless you've come to a previous workshop in the past. We can actually look like over the last year, I've had all these different runs. The green means they were successful. Red means there was like a bug. That was me testing something most of the time. Purple is a task that I terminated. And you can see all these different versions of workflows that I've been running. And we're going to go ahead and create those in the notebook and then run them in this remotely in Union Serverless here. Awesome. So it sounds like people are able to sign in. Thank you so much for letting me know in the chat. That's very helpful for me. Once you're able to sign in and maybe see that platform or you get the onboarding email, we can go ahead and run this next code cell. This is going to be us authorizing Union from our notebook here. And then we're able to basically take stuff that we write in Python here and then run it on the Union cloud, which is cool. So to authenticate, navigate a browser, click this link that gets generated here. And then just hit next. It's going to auto-populate that code. Go back to the notebook. It should take a second here. And it says login successful. Awesome. So once we've done that, now we should be authorized to write Python code here, those tasks and workflows, kind of like we talked about in our pipeline, and then push those up and run them on Union, which will be really cool. Also, a quick note. So we're using Colab Notebook here to write our code. I think it's really easy for these workshops. It makes it really easy for you to kind of grab stuff and run it. In Colab or in Jupyter Notebooks in general. So Google Colab is Google's way of hosting a Jupyter Notebook kind of in Google Drive with their own instance where you can run Python code. You can use this magic function called write file. This isn't a Union or Flyte specific thing. This is specific to Jupyter Notebooks and Google Colab. Here I'm saying write file simple workflow.py. All this is going to do is basically all this code we write beneath it in Python. It's going to save that to a Python file, that simple workflow wf.py. And then we're able to run that Python file with Union or Flyte. But just want to call that out. So usually, like if you're actually doing development with this, you'd be writing .py files, probably not in a notebook. And then you're going to use these commands that we're going to run here, targeting your Python file. And this write file is just simply an easy way of doing it for a workshop in Google Colab or Jupyter Notebooks, which is pretty cool. So here we're importing from Flyte, which again, Union's built on top of Flyte. So we're using the Flyte SDK here. And then we're using the Union kind of command line interface to interact with it. We're importing Flyte, or from Flyte, we're importing something called task and workflow. Those are kind of the core things of building workflows. Is you have tasks, which if you remember from like slides, let me go back real quick. Oops. Like looking at a workflow like this, each one of these is a task. And then the workflow is basically all of them tied together. And you're usually passing data from one to the other. Someone said they logged into serverless. Yeah, we'll and they asked about default projects. We'll come back to serverless in a second. Let's run this first workflow and we'll actually push this up there and then we'll explore the interface a little bit, but it'll be more fun for you if you have something in there to take a look at. All right, so we're importing tasks and workflows. These are the core building blocks of the things we talked about. And then to make a Python function a task, all we really need to do is add this decorator on top. And then we'll talk more about stuff we can add into this decorator when we build our more advanced workflow. But for now, we add a decorator. This now becomes a task. And then a workflow is running those tasks, or in this case, just one task, but you could build a whole series of tasks, which is what we're going to do next. And a workflow is going to be running those tasks. And here we talked about strongly typing in the tasks and workflows. Basically, we're defining a variable name is going to come into this function, and then we're just going to print hello name. but we're saying it's a string. So if we try to pass an integer or something, again, it would throw an error on us. And also it's expected to be a string when it comes out of the task as well. All right, so let's go ahead and run this code cell. If you don't run this code cell, you won't have that .py file. You can also explore all the files and folders by hitting this little file icon, and we can actually see we have this simple workflow.py file now. I'm gonna exit out of there. And then we can run this locally now in our environment, Google Colab. So we say union run, and then the file where your workflow lives. And then our workflow in this case is called main. So we're saying main, and then we're passing in a variable that it's expecting. So it's expecting a variable to come in. So right now it says Flyte. Let's go ahead and run this. And it's running locally on Colab, so on your compute resources here. And then we could change this variable. So I would recommend put in your name. I'm going to say Sage. So instead of saying hello Flyte, it's going to say hello Sage. And then let's run this remotely. So now we're saying union run remote. It's going to go to the Union cloud, which so Flyte and Union, they're built on top of Kubernetes. So you can set up your own cluster with Flyte. You can also set up a bring your own compute with the Union platform, which offers some other features. In this case, we're using serverless, which has compute just kind of up there for you to grab. I mean, we'll talk about defining compute resources like we talked about earlier in the slides, how to do that in our code. But we ran this simple workflow. So go ahead and click on this link that gets generated. And it already ran so fast for me that it's already succeeded here. But we can see that this is our task inside our workflow called Hello World. You can also get this other view where we can look at a graph. And again, this workflow is pretty simple. We'll see a more complex one here in a minute. But we can see this Hello World. You can also see a timeline view and see like how long it took. So it took 4 seconds to spin up and run that for me. So now we can see, I kind of like this graph view personally. I guess if you had a ton of tasks, this would probably make more sense. But I'm gonna go to graph view, and I'm gonna double click on or just single click on this node or this task, and we get some information about it. And we'll see more advanced information that we can get in other parts of the or other tasks later on in our pipeline. But we can see execution. We can go look at live logs here. We can see inputs. And in this case, the input was Flyte. And then we can see outputs. And so it says, hello, Flyte. That's what was returned out of our task. And we have some other information about our task here. One really cool thing is now that this workflow and task is up here in the UI, and this ran on the compute that is through Union serverless. So there's a GPUs you can access as well in here. So someone asked about like, why would you want to run this in Union versus right in Colab? So you get access to all those things we talked about, like versioning, all of the inputs and outputs are kind of logged here. All the artifacts for models are going to be logged here. Again, we'll see a more advanced workflow here in a minute, and it might make more sense if it doesn't already. But then also you have access to this compute like running on GPU. So our workflow here is incredibly simple, and the ML workflow we're going to build here in a minute also doesn't necessarily need GPUs. But if you're using something like deep learning, like someone was talking about earlier, you often want to train a model on that or run batch inference, like you can have a model through this UI and then pass in new data and get predictions on it. You can do that on the compute that's provided by Union. So here, though, let's go out and hit relaunch. So we're going to relaunch this whole workflow. Again, it's just one task, but we can relaunch it from the UI. And then actually, instead of putting in our name variable when we called it here, we can rerun the whole workflow right from the UI and just put in a new string here. So again, I'll say Sage. You can put in your name, and I'm going to hit launch. And now it's going to rerun this whole workflow. I say whole workflow, but it's one task. But you can imagine that when it comes to machine learning, this could be really useful if you have hyperparameters as an option to pass in. And instead of rerunning everything all the time from your notebook or from your CLI, you could actually just go into the UI here and rerun it with different hyperparameters and then get different results. And then you have a log and a version of those every time. And you could download like the best model that you find. So now we can see the input here was Sage, and the output was hello, Sage. Any questions so far? I know we're diving into a lot here. Also, someone mentioned what is like a default project. So we'll see system here in a second in action, but by default, the projects that we're writing with our workflows are going to be under this default project name. And here I can view all my different workflows that I've run. Again, I have a lot because I use this platform a lot. You'll have just the one or two that we just ran. If I go back and go to systems, yours will probably be blank in here right now. But this is where you do things that are like system tasks, like building container images. And again, we're going to build a container image here in a minute. So we'll actually see this in action as well. Any questions so far on the UI? I think I've caught up with the questions that were coming in on chat. And I saw someone said their email arrived. Awesome. Yeah, sorry it took so long. Oh, I think it was just a couple of minutes for you too, actually, maybe. All right, so I'm going to go back to my notebook. Again, if you have questions, put them in the chat. I'm watching them. If you also kind of forget, like, or you're taking a task that someone else wrote and you want to look at what are the required like variables that you need to pass in when you run a workflow, you can hit -- help on that workflow, and it says, name is required, so we have to pass in that variable to run it. If you also want to look at just more options of stuff that you can pass in, we won't get into all of these, but you can get pretty advanced with it, of all these different options that you can pass into Union or Flyte when you run your workflow. And then I have links up here too to check out the docs for tasks and workflows. There's a lot more you can do with them. But we'll see a little bit more of that in action here in our next code cell, where we're going to write that machine learning workflow. All right, so again, we're going to create a container image that's going to contain all the libraries we need. We're going to download a data set. We're going to process and visualize that data. We're going to train a machine learning model. We're going to evaluate that model, and then we're going to save that model to Hugging Face. So if you don't already have the Hugging Face account and you want to do that last step, sign up. Again, if you don't put it in, everything else should run. I think just that last part of the task is going to fail, which is fine if you don't want to do that part. So you can go to Hugging Face, make an account if you don't already have one. And if you are getting more into machine learning and LLMs like people were talking about, you're going to want to have a Hugging Face account probably at some point anyway. So I'm going to go to settings. And then I'm going to go to access token. So this is going to allow me to write and read files from my Hugging Face hub. So if you don't already have a token, you can create new token here. And then the only permissions I need to give this token is read access and write access to my repos. And I'll just say workshop. What's the date? You can name this anything you want. I'll just say workshop July 24. I don't need to copy that. And then I'll just hit create token. And now I have my token here that's going to grant me access to read and write files from my model hub. I'm going to come back over to my notebook, and we're actually going to use something called secrets here to manage them inside Union. So we can say Union create secret. I'm going to call this Hugging Face token. And then it's kind of hard to see if you're in dark mode, at least, that there's this little box here. You can paste that token in and then hit enter, and it'll save. I already have a token called this. Actually, you don't change this part. Just save it as Hugging Face token. I'm going to say, hey, save mine as Hugging Face token 2 because I already have one. So just hit enter once you put that in the box. And oops, I got an error. I think that, because I was already running it before I changed the variable name. And I already have that token here. So now if I do this again, enter, should be good. And then I can hit Union Get Secret, which will show me all the secrets that I have. So secret is a way to manage things like your authentication tokens. And then you can just call them from Union in your workflows directly. And then you don't have to worry about managing them locally or accidentally storing them as strings or something where they can be publicly viewed. So now I have several in here. I have Hugging Face token 2, and then I have some other ones that I was working with on other projects like Weights and Biases key and OpenAI key, but you should have just one. Cool. And someone said, all good, happening exactly as advertised. Great. Awesome. Very, very great to hear that it's going smooth so far. And this is going to be, I think, the fun workflow. So if you're following along, now we're going to kind of get way more into some machine learning stuff here. I'm importing several libraries. Don't worry too much about some of the formatting ones like HTML. We'll see where those are used here in a second. But then we're importing some things from Flyte. We'll talk about these as we use them. And then we're importing pandas and scikit-learn. Again, scikit-learn is that popular machine learning model that we're using today, or machine learning library that we're using today to train our model. And trying to think if there's anything else to really call out. We're importing Hugging Face Hub to save our model. This is going to be the data set that we're going to use that's built into scikit-learn. But again, you could bring in your own data. All the stuff that we're going to see today, like it might be kind of a simple machine learning workflow right now, but all the stuff we're going to see today can really expand into more complex models and more complex workflows and data sets. So if you're working with something more interesting or an interesting data set, you can kind of rewrite this a little bit to pull it in, and it should work great. Someone said they missed what to enter for secret value while creating Hugging Face token. Again, if you don't sign up for Hugging Face, that's okay, and you can come back and rerun this part. I'll quickly show it one more time. You can go to Hugging Face if you have your Hugging Face account, go to settings, and then go to access tokens, and then create a new token. It'll need read and write access to your hub, which is going to be where it saves a model, and then we're going to pull down a model. Give it a token name. It could be anything, and then scroll down to the bottom, hit create token, and then this is what you're going to copy in when you run that code cell. And again, if you don't do it right now, you can always come back after the workshop or whatever and do that part again. But I think most of the code should run. I think you'll just have a failing part in that last piece. So if for some reason you didn't want to create an account right now, you should be able to still run most of this workshop. All right, so we've imported our libraries. And then has anyone ever worked with like Docker before or container images? I don't know if you love writing Docker files or you might hate it, but we have this really cool feature built into Flyte and Union called image spec. So right in image spec, you can define like all the packages you want. There's even more stuff you can do as well. You can look it up in the docs about like defining apt-get packages and stuff in here, stuff like that. But in here, we're just importing or downloading the libraries that we need, like scikit-learn, matplotlib, all those ones we saw that we imported earlier. Joblib is a library for like saving and loading machine learning models from scikit-learn. So when we run this, it's actually going to kick off a build for that image. And you'll see that when you go to systems, once we run it, you'll actually see it's like going to create an image in here. I'm already going to have this image created. So once you do create the image and it contains all these exact versions of the libraries, if you run it again, it'll say, hey, that image already exists. I don't have to build it. And I can just pull it into the project right away, which is very cool. Then we're going to, so I'm going to go through this code kind of quickly. And hopefully it explains what's going on. And then if I need to come back to it, I can. But I want to make sure we can run it and actually look at like the results. And then maybe we can come back to the code if people have questions on it. So this is converting a figure to HTML. You'll see this in action. We're going to basically create a classification report when we evaluate the model, and then render it inside our task, which is a pretty cool feature. And then here, we're creating our first task called download dataset. And like I'd mentioned, you can add some stuff inside of that task decorator. So this is like declarative computing here, where we can say, we want that caching feature that we talked about in the slides earlier. So this is going to allow us, when we rerun this workflow, which I'll show you how to do, again, either from the UI or the CLI, if cache is equal to true, it's going to pull data from the cache results. So it's not going to download that data set every time. And our data set here in this example is kind of small, but if you have a very big data set, caching it can save you a lot of time or compute resources. And you can also change the cache version. So if you do want it cached, but if you're doing updates to the code, you can change the version here. Then we're specifying the specific container image we need for this tasks. In this case, we're just creating one image and then using that for all the tasks, but you could create different images as well and then use them for specific tasks. Like if there's a much bigger library in one and you didn't want to import it for every single task, you could do it that way. And then we're defining exactly how much compute we want for this. So again, remember we talked about earlier, like you might want a smaller amount of CPUs or GPUs for a task like downloading a data set. You probably don't want any GPU. And then if you're training a model on PyTorch or something, you do want GPUs. Well, you only want to spin up that compute for those specific tasks and not have those GPUs running the entire time. So then we can specify exactly what type of compute we want for each task in this kind of request resource section. You'll see this in all the other tasks we're going to run here today. It's going to look pretty similar to what we did here. So here we're downloading our data set. This is a built-in data set to scikit-learn. So it's downloading that, and then we're loading it into a data frame, which is a way to store and kind of look at data in Python. And this next task is process the data. We're enabling deck. We're setting it to true. This is something called Flyte decks. We'll see what this looks like in action, but it allows us to store really cool visual elements in our task. So I'm using this to kind of look at the data after we do pre-processing on it. And I always do something like this as a sanity check when I load in data to a machine learning model. It doesn't always have to be with a pair plot like we're going to use today. But for example, going back to the computer vision example we were talking about earlier, if you're doing something for object detection, you're loading in a data set, you might want to load in that data set and then one set of annotations just to make sure that you're reading them both incorrectly and that the bounding box is around the object correctly. Because there's been times where I could have swore I was loading it in correctly and I wasn't, and I was wondering why my model wasn't learning anything, and it's because I loaded in the data incorrectly. So I always really like to have something like that as a sanity check on my data. And then here we're going to process the data set. Again, we use typing here, so it's expecting a data frame to come in, and then it's going to return a tuple of 2 data frames. And if that deviates at all, again, it's going to say, hey, something went wrong here. You passed some data that I wasn't expecting. Here we're going to do a train test split. So we're going to train our model on 80% of the data, save 20% of the data to do evaluation on. And then we're stratifying on the target, which means we're going to try to get an even amount of all the different 3 classes in our data set. We'll see again when we visualize the data that there's going to be 3 different flower classes. We saw like one image of it earlier in the slides. And then we're going to create a pair plot from the data set and then log that in our deck. So this is going to be a really useful visualization that we can quickly kind of do exploratory data analysis or a sanity check on our data right in our workflow, which will be really cool. And then we're going to train a model. Someone said repo ID. It's a repo ID. so like Hugging Face repo ID. I'll get to how to populate that in a second. And then, sorry, that threw me off. We're training a model. Again, we're saying we want the container image. Here, we're upping the CPU amount to 3 to give us a little bit more compute to train our model. And then also we can add more memory as well if we want. And then here, we're just training the k-nearest neighbors. We're setting the neighbors to 3. So again, we talked about in the slides, it's going to look at the closest 3 neighbors, make a decision on what that new data belongs to. We're training it with this model.fit. And then we have evaluate model. We're going to take in that model. We're going to take in the test data set, and then we're going to compute some metrics on it to say like, how good is it performing for classification in this case. And then we're going to append this to the deck. Again, we'll see all this in action. If this looks confusing, it'll make sense here in a minute. I'm going to quickly go through this. And then we have another task that's uploading the model to Hugging Face Hub. So we're going to import that secret that we created before from the Hugging Face token. And then we're initializing the Hugging Face API. We're going to pass in a repo name, the token, and then we're saying exists true. That means if we rerun this with the same repo name, it's not going to create a new one and it's not going to throw an error. It says, oh, okay, cool. It exists. That's okay. We're still going to upload the model to this repo, even though it already existed before. We don't have to create a new one. We're saving that model with the job lib. And then this is what we pass into the Hugging Face API, the model name, which is where it lives in our Colab notebook environment. And then path in repo is what we want it to be named when we upload it. We're going to use the same name in this case. And then we're going to pass in the repo name where do we want this repo to live, or where are we uploading this model to? And then you can edit this commit message. I'm just saying upload model in this case. Repo type is none by default. It's just a repo where you can upload any file, but they have special kinds like for data sets. And then we're passing that token. And then we're combining this all together in a workflow now. So we have all of our tasks and we're creating a workflow. We're stringing them together. We're calling download data set. Then we're passing in that data frame to the process data set. And then we're passing in the training data set to the train model and the test data set to evaluate model. And then here someone asked, like, what is repo ID? We want to give the username of our Hugging Face account and then a repo ID here that we want to create. And that's going to create a new repo in our Hugging Face account and then upload the model there. So also make sure you hit run on this code cell if you didn't already. And it's going to say writing workflow.py. Again, you can view it here. Now there's a .py file. And then if we forgot what were the inputs that we needed to pass to our workflow here, we can run that .help or --help. And it says it's expecting a repo name and a model name. So before we run this on remote, you'll want to update one thing here, or these two things, is if you made the Hugging Face account, you should have a username attached. So again, you could go to settings or any page where your profile is. My name is Sage Codes, so I'm going to populate that username with that part, but you would populate it with whatever yours is or whatever your token can write to. So I'm going to say Sage Codes, and then you give it a repo ID. This can be any string that you want. So in this case, we could say ML Workshop, and it's going to create a new repo for me. If I gave it an existing name here, it will just upload the model to that existing repo. So keep that in mind. And then we're passing in the model name. We're just going to call it model.pickle, which is a file format to save that type of model in. So now if I run this, and let me know if you were able to get it to run as well. For me, it's saying running execution on remote. And then for me, it already has an image. So it's skipping the build. But for you, if it's your first time running it, it'll say building image. So you might take a minute longer or a minute or two longer because it's going to go ahead and build that container image containing all those libraries that we need. And then it should generate a building link kind of like this. And you could click on it and it would take you to systems and then take you to a task that looks like this where it's going to build that image. And if you wanted to, like, you could look at the live logs as it's building and see what's going on. For me, I'm going to go ahead and go to my execution. So you can see, again, yours might take 2 minutes or a minute more to run, but then you'll get something that looks like this. So I'm going to go ahead and talk through it. And then you can come back and look at yours as it's going. You can see mine's actually going, though. Like, it's still uploading the model, it's spinning. All these other ones are green. So I'm going to note a couple things. Is one, if I hover over this, yours might not say this because you didn't rerun this workflow yet, but when we relaunch it, which I'll show you how to do from the UI again, it'll say something like this. It says output for this execution was read from cache. And if you remember in our notebook, in that first task, we were downloading data. We said cache is equal to true. So the first time it's going to run it, and then it's going to store those values in a cache. So it doesn't have to re-download that data set every single time. And if I click in like we did before for our very simple workflow before, I can see inputs were nothing for this, but the outputs were this storage which contains our data set. And if I go over to this process data set, I can look at my inputs. Again, we're the data set here. And then I have outputs. It outputted 2 data frames, if we recall correctly, train and test. And then you'll see this new button here called Flyte deck. That's the thing that we created when we said deck is enabled to true. You can also change the order of these. I forgot to do it here. But metrics is this new tab that we created containing a pair plot of our data. So again, there could be different use cases for this. Like I had mentioned, I always love to do a sanity check on my data when I read it in. Like I had mentioned, my mishap with reading in annotations incorrectly on a computer vision data set. So for this, it's kind of like I can look, this is all the distribution of my training data. So the iris data set contains 4 features: petal width, petal length, sepal width, and sepal length. Sepal is kind of like an under petal of a flower, kind of. And then based on all those features of just these lengths and widths of the petals, basically, we're able to train a model to predict what class of flower what class of flower a data piece belongs to, just by looking at these widths. And then we have the hues changed on target. So we can kind of look at this quickly and get some good insights about our data, like would our model even perform well, or what type of model would perform well. In this case, we can see that they kind of are clustered in a lot of the views. If you look at this kind of like bell curve overlap thing, this is a really good indicator where, this class 0 of flower basically doesn't overlap at all with the other one. So we should do a really good job of predicting what class that belongs to just based on the petal features. Somebody said they had upload to Hugging Face fail. I would just make sure that you put in your authentication token, and then also make sure that you put in your username correctly when we called it. And we can troubleshoot this a little bit later as well. I'm going to continue walking through this real quick, and then I can help you there, probably, hopefully. So now go on to the next task. We trained our model, and the inputs here were the training data set. Outputs were a model. We can actually see it's a scikit-learn estimator blob. And then that went into evaluate model. And we have a Flyte deck here again. And if you recall, we actually generated a classification report in that task, and then we saved that here. And we actually moved it over to the beginning, which is kind of nicer to look at. And here we have like how well our model did, which looks like it's doing great. It's a pretty simple machine learning problem here, but you can save things like really cool visualizations, even interactive ones. Like if you want to use something like Plotly, you can do this here. And then you can have like classification reports. So now you have a log of all these artifacts, like the inputs, the outputs for every single task. Again, like I mentioned, these are all version 2. So we'll rerun this workflow here in a second, and then you could go look at these specific versions. We could set it up where we could relaunch the workflow from the UI and change hyperparameters or change data sets or change model types, and then be able to look at all those results just like we did now, but like by quickly changing things in the UI, which is really cool. And then we had our last task here, which was upload model. It says model uploaded to Hugging Face Hub. And then this is the path I kind of messed up. I think here it should be sagecode/ML workshop. And then I should have put another slash. So it would say it was model pickle. And if I go to my Hugging Face account, let me go back. And I have my new repo that was created 5 minutes ago. And inside of here, you can go to files and versions. You can upload a README here as well if you want this to look better. I go to files and versions, and I have my model pickle file, which is awesome. And then I could go back to my notebook, and I'll come back into the interface and get to other questions here in a second, but I'll go ahead and finish out the rest of the notebook. If we want to download this model from the Hugging Face Hub, what we need to do is pass in that token. Oops, I might have exited out. So I should probably build this a little bit better next time for the workshop, but I'm going to go grab a token again. Settings, access token, another token. And this one actually probably just needs read access, but I'm going to go ahead and give it both again anyway. Create token. So hopefully if you still have this token saved from before, you can now put this in here for the Hugging Face token. And then we want to give this the right repo ID and username where you saved your model. So if I went back to my account again, into my hub, you can also remember it from what you put in before, but you can see that it lives at the sagecodes/ML workshop. Again, yours is going to be your username and then whatever the hub name, the repo name is that you gave it. And then paste that in here as a string. And then we're looking for that model.pickle file. And then we're going to assign it to this model variable. If I run this, it's going to open up that model. And then now we have access to it. And then we can see it's a k-nearest neighbor classifier. And then we can pass in new data. So here's just some integers I made up to give it, and it's going to return predictions. Yeah, it's going to be return class 2 and class 0. This is just a warning saying it was trained on a data frame with feature names. This doesn't have feature names in it. It's totally fine. Don't worry about that. And then so we went through like a whole pretty, like it might have seemed like a simple workflow, but we actually kind of used some really complex tools. And if you never even trained a machine learning model before, we went through and trained a machine learning model. Not only did you train one, but you built a reproducible, really reliable pipeline that you can rerun and build your own projects with. And then also how to save a model somewhere and like pull it back down. This is really cool. Like, has anyone ever done something like this before? Someone asked a question, repo ID. So I'm not sure which part you didn't replace, but you always need to replace anything that has that placeholder of repo ID with the repo that you want to save your model to, or that you're pulling your model down. Actually, if you had repo ID here when you ran that workflow, it should create a new repo called repo ID. You just have to make sure you put in your correct username here as well. All right, so I'm going to go back in the interface here a little bit, and we can relaunch our workflow. And in this case, I should probably add more fun variables here to mess around with. Like I mentioned, you can rerun this workflow. You could pass in different parameters if you set it up that way. We didn't. In this case, we're just inputting a different model name, or we could input a different repo or username here for Hugging Face to save. But you can imagine setting this up with like different models that you could pass through. So if you want to try k nearest neighbors, but you also want to do decision tree and random forest or whatever, you could have it set up in your task where it could take in a string and then run a specific model type based on that. But hyperparameters is a big one. So if you're doing something like deep learning or even k nearest neighbors, we set it to 3, but you could have that as an input here and then experiment and get all those things that we saw generated. Like someone said, that's pretty slick earlier. I was assuming that's about the embedded visualizations. But if it was on a different feature, let me know. So we can hit relaunch. I didn't change anything. You can launch again. It's just going to run the whole workflow. Oops. And we can see if this is your first time rerunning it, which it probably will be, you can see that this went almost instant this time because it didn't have to download anything. It's reading from those cache results. And then now it's already going on to processing the data set. And then it's going to train model. Amber said their token didn't have the write access. So if you're creating for that first part, you need read and write, or I guess you might just need write access. I think you do need read and write to make sure that the repo exists, and that's fine. Train model, evaluate, uploading to Hugging Face. And also, I think by default, if it doesn't detect that there's actually any changes in the files, if you hit this upload to Hugging Face again, it doesn't. I think it skips uploading if there's not actually a different file. Like we can see that the model file is exactly the same. So if you looked at some output, it would actually say like, oh, skipping upload because there's no new files. But if you were to train a different model with some different parameters and it was a different file, then it would come up here with whatever commit message you passed in. So you could also have that as a variable that you pass in. Be like, what's the commit message when I want this model saved to a Hugging Face? So I want to ask, can I show again where visualizations are? So we have 2 in our pipeline. We have one in evaluate model, and we have one in process data set. So if you open up process data set, you'll see this little button called Flyte deck. And I'll show how we made this again too. So we go to Flyte deck, and then we have this embedded pair plot, which is under metrics. By default, you have these other things in here too. So we have timeline, we have the source code. So this is actually kind of useful to see too. You can just enable Flyte deck on any of the tasks, even if you're not putting custom metrics. And if you just want this all kind of very easily visible in each task, you could do that. You can look at the input. We can actually see the input here was the data frame, and the output for this task was those 2 data frames. So we go look at metric again. This is our pair plot. That's kind of like, again, sanity check or a kind of quick exploratory data analysis of our data. And the other one was in evaluate model. Open up Flyte deck again. We can see our classification report and other metrics of how our model performed here. And if I go back to the code, I can show you how we created it, where we went in process data set here. And all we're doing really is enabling deck is equal to true. That's going to create that Flyte deck button and all those default things that we showed. And then here, I created that pair plot image with a library called Seaborn. And then I'm passing in basically a new tab into the metrics or into the Flyte deck. And I'm calling that metrics deck. And then I'm appending that converted figure, that basically that pair plot that uses that convert figure to HTML function. I'm appending that to metrics deck. So it takes like a list here. You can embed more than one thing, which we did in the other one. And then basically once that's appended and the deck is equal to true, now that visualization is going to be embedded directly in your task, which is really cool. And if we scroll down, the other one's an evaluate model. This has a little bit more going on. It's using matplotlib. There's a little bit more to setting up the plots. And then we're also embedding more than one thing. So we're doing 2 appends here. Metric deck, the first one, that's the first figure. And then we're appending the classification report. And you can actually embed some slight HTML here. And like I mentioned, you can actually use something like Plotly as well if you wanted some more like interactive visualizations in there too. And then I reran this, and if you kind of like, well, first, if you just X out the little side panel, you can see it's related to this other run. So every time you run something, you get a new kind of hash ID here. And so everything is versioned like we talked about. So if I went back to this original one, um, again, our data is the same here because we just reran the same thing. But I could go explore like what changed and look at all those different outputs for each time I ran this task. And again, everything's versioned here. So if you wanted to pull the code, if you want to pull the specific data, if you want to pull the specific model from these different versions, you can now do that, which is pretty cool. And then also we're saving a model to Hugging Face. So if you wanted to have versions there, you can, and then you can pull this model down anywhere. So one example too of that is that if you wanted to save a model and then pull it down on an edge device like a Raspberry Pi, you can easily do so with basically what we just did here. That's kind of all I had prepared to show. What did people think? I see some people saying it's awesome. That's pretty neat. Has anyone used any tool kind of like this before? And if so, like, how did this compare? And then I'd love to hear like what you just thought about in general. Does it seem fairly easy to use? I know there's a lot going on, like in the UI. If you've never opened it before, does it seem pretty intuitive though? And if you have feedback later too, and you join the Slack channel, like please let me know any feedback you have there later. Like if you actually use this in a personal project or a project at work, and you encounter something you don't like, or you encounter stuff you love, let us know. It's always fun hearing about how people are using the product and hearing about the things they like, and if there's anything you don't like, how we can fix it. And we've merely only kind of like we went through a lot of the core stuff here, like tasks and workflows. That's how you build your pipeline like this. There's a lot of other functionalities that we didn't get to that we're not going to be able to get to today in this workshop. Like you can have launch plans. Forget if I have any in here. So everything I think has a launch plan tied to it, but you can create custom ones here where you could say, run a pipeline or run a set of tasks like every minute or every hour, pull new data and then like provide it to another workflow. So a lot of cool stuff. Artifacts we didn't touch on today. It's basically a way to more to track those artifacts that we talked about that are generated a little bit better, and you visually see like lineage for all of the data generated and where it's used. So I might add that in next time too. Someone said they can't create a new union secret with HF token, probably because I'm guessing if you're getting that error, you already have a token created with that same name. So one, you could give it a different name. Also, I have this commented out here, but if you want to delete a token, all you have to do is run union delete secret token and then pass in the token name. So in my case, I'll delete that number 2. And also, if you want to list all the tokens you have, you can hit that union get secret. This is going to show all the ones you have. So I'm guessing that if you're getting that error and it says you can't create it, that you already have one called that. So you should run this union get secret, see if that name is already there. One, you could just use it if it's correct. But if you want to delete it, you can run this union delete secret and then pass in secret name. And it deleted, and I can rerun this and I can see which secrets are in there now. And it's gone. How are people feeling now that they went through all this? And I know it can be a lot, like I said, it could be fast paced, could feel challenging. If you've never done a lot of machine learning before, maybe you're even like, what is this train test split thing? And you need to think more about it. Someone asks, is there any paid course by me? No, I don't have any paid courses, but I do love doing a lot of live workshops and stuff. So I do them for work using like Union and Flyte. Also, I haven't done one in a little bit, but I really like doing other workshops out of that too. Like I did an intro to machine learning not too long ago. And I do plan on doing more in the future, but I don't have any plans of necessarily making a paid course. But good to know that people are asking about it. And we're creating a whole bunch of really cool new material right now at Union on basically MLOps and pipeline stuff. Again, not a paid thing, So keep an eye out for more courses or workshops like this, and then also just a lot of tutorials. So check out our blog. We're putting a lot of stuff on there. Go to Union AI. You can go to blog, go to events. I'll be posting more events soon. Someone said, oh, they need to delete the old token. Yep, I think if you, oops, I might have added a character to this link. Yeah, I think you're running into the issue that you already had the token created, but you could reuse the old token if you wanted as well. And I keep seeing people join in, so I know it's pretty late because we're over time. We're gonna wrap up this workshop here soon, but I will just say you can watch this recording, and if you want to follow along, all the links are in the description, but I'll share them in the chat one more time as well. And if you are just joining now and you want to use Union and run through the notebook later, I would recommend going to that sign up link right now because we might have a little bit of a longer wait list outside of the workshop. So if you're interested in trying this out, even if you're not going to do it the second, hit that sign up link right now, and then you'll get access to Union serverless. And of course, the GitHub link is here. Again, if you're watching a recording, should all be in the description, but I'll share these in the chat one more time. Awesome. And someone said, this is pretty cool. Would love to try it with different models. Do you have a different model in mind that you would want to see an example of? So I'm building out some different examples right now as well. And like I mentioned, one's going to be computer vision. Probably a couple in computer vision. Like we could do a computer vision classification. I really like going a little bit further and doing something like object detection. And I think it was Amber who had mentioned, people talk a lot about training the model, but not about the annotation piece. So I do want to bring in the annotation piece and actually maybe partner with one of the annotation companies, and they could even talk about it more if they wanted. But this really cool is like using Union or Flyte, tying all these different tools together. You can bring in, pretty much any model you want and any data, and then get this infrastructure that we kind of quickly went through. Again, there's a lot more like features and stuff that we'll probably touch on other workshops. Cool. Said they were thinking about object detection. Perfect. You already have some code ready to go basically for that, and I need to make it into like a better workshop tutorial format. Amber said, great presentation. Thank you. Always really fun. I love doing stuff like this and showing people like hands-on examples of using different tools. So if you have different tools too that you want to see examples with, let me know. So like someone was talking about object detection. I think someone else was talking about computer vision before as well. We'll build examples with those for sure. I think someone also mentioned LLMs. I know we've done an example of fine-tuning a large language model as well as an example of building like a RAG pipeline. But we'll definitely be doing more of those as well. Yeah, someone said chat with Llama 3. I have to look at the fine-tuning capabilities or something we can do with it for sure. Like we could do chat with it, but I want to have something kind of fun of, maybe building a RAG pipeline, which is bringing in your own data and then being able to embed it or create embeddings from it and then query it with something like Llama 3. That would be pretty cool. Someone else said, thank you. No problem. My pleasure. Thank you, everyone, for coming. And especially everyone who talked in the chat and asked questions and told me when things were working or were not working. That's very helpful. And it's way more fun for me to actually see people, following along and asking questions. And again, if you have other thoughts on this later, let me know. Connect with me on LinkedIn at Sage Elliott, or you can also find me in the Slack channel. It's pretty active. And like I mentioned, doing a lot of fun stuff too, like the AI book club we talk in there. That's been really fun. And then I think we're also going to do some other community events, like people have been asking for paper reading, which is something I want to do as well. So check it out. I think we're building a really cool, not just product, but community. And that's in the open source community there as well. And I think I had a link before, but you should check out Flyte on GitHub as well, which again is what Union is kind of powered by in the back end there. That's the open source version of the platform. And give it a GitHub star. It's always fun to see these stars go up as well. Someone said perfect with RAG. Yeah, I think it'll be a really cool example. with a RAG pipeline, and maybe even we'll do like a fine tuning and RAG in that workshop, which would be kind of cool. Then you really kind of come away with a lot of the knowledge that you need to make applications. Obviously, it's like getting data and evaluating it. That can be hard. Also, I want to work with creating some more end-to-end examples using like ML monitoring, like I've talked about at the beginning. That was something I kind of worked with in the last 2 years. Is like how to monitor tongue twister, monitor models in production, and evaluation with LLMs before they go in production. So like, what are metrics you can look at to make sure that your RAG pipeline is improving answers, or that fine tuning is actually improving, or prompt engineering is improving it. And that would be something that would be really cool in this pipeline. Is you could build out you could build out a pipeline and maybe adjust prompts and then get evaluation return for like 10 set of different system prompts that you're giving it. That'd be kind of cool. But yeah, it's something like this is what most people use as well to create RAG pipelines. Like you might, for example, I'm just going to use Wikipedia as an example, but it could be anything like scrape Wikipedia or have access to data somewhere. You're going to download that data or ingest that data, like if it's in PDFs, or it could be multimodal RAG too, where you have things in like images, videos, audio. You could actually use OCR to get text out of a document, something I did recently. And then you can create an embedding from that data. And then there's different ways to create those embeddings too. So it's very interesting, like talking with people, working with a lot of RAG in production. You might use another library like NLTK and remove stop words. And you might actually do like some improvements on generating the embeddings in that case as well. So you can actually build a whole pipeline with those types of things. And then again, have it all versioned here and have those evaluations like embedded, and then basically test which version is best too. Awesome. Well, I know I'm streaming way over the hour mark here, but I'm just hanging out answering questions as they come in. But I probably will end the stream here soon. So does anyone have any last minute questions? Or again, let me know. Is this tool interesting? Would you like to see more workshops and contents with it? It sounds like people are interested. Seems like people said it was really cool. There were some really slick features, as someone said, and computer vision examples and LLM examples. That's what people are talking about building. Someone said 100 emoji, hand. Awesome. Again, yeah, thank you everyone who came in, and I still see people hanging out. So if you do have any last minute questions, I'll hang on for another minute or two, but then I'll go ahead and wrap up the stream. And I hope to talk to you all later at other workshops, but also again, connect with us on Slack or LinkedIn. And I always love hearing about what you're working on. And especially if you take what you learned here today and then actually go like build something else, even just like a hobby project or personal project. Also love seeing that type of stuff too. So feel free to, tag me in your LinkedIn post that you make about it, or share it in Slack. Awesome. All right. Well, I see people dropping off. I don't see any other questions. So again, I'm going to wrap up the stream here, but stay connected with me and ask those questions as they come up later. Have a good day, everyone. I'll talk to you later.